Let me start with my usual greetings, especially in the beginning of a new semester, the winter term now. Dear members of the European Academy of Sciences and Arts, dear colleagues and friends, dear guests, I would like to welcome you again to the opening of our Arts Meet Science lecture in the winter semester. Thanks to the two deans, as every year, our two deans of the art and medicine classes, Violeta, Dinescu, and Dušan Šuput, who have once again together put this program together in a very nice way, I think. Now tonight, one lecture is about creative education, and the other about the relationship between art and life sciences. So both lectures are about creativity, how it arises in nature and how it can be realized in education. In nature, we observe how complex atomic, molecular, cellular, and organic structures organize themselves. They are often characterized by astonishing aesthetics. In the theory of complex dynamic systems, we can now not only model this mathematically, but also simulate it on the computer. This is also one of my main areas of research. The emergence of new structures in nature can be quite disruptive, surprising, and chaotic. In mathematical terms, this is called phase transitions at critical points, when systems become unstable and these new structures emerge. Creativity and the emergence of new things in nature and life can therefore be understood using mathematical methods. This is an important message for education, our another talk. The promotion of STEM subjects, you know STEM, the international abbreviation for science, technology, engineering, mathematics. The promotion of STEM subjects must be combined with the arts and humanities. Creativity, which makes the discovery of new things and innovation possible in the first place, should be at the center of this. The school system needs to be better prepared for this kind of integration and cooperation. Our European Academy of Sciences and Arts could play, I think, an important role in this. I look forward to further inspiration this evening and a fruitful discussion. I thank you for your attention.
Thank you, Klaus. It was, like always, a very nice introduction. And now it's my pleasure and honor to introduce VELIMIR SRIČA, who is coming from neighboring country and speaks also Slovenian, as I saw from his CV. His career has started as in economy, going further to electronics, and then he was also he obtained MBA at Columbia University, and then his work continued at UCLA in Los Angeles, in Shanghai, Beijing, Dubai, nearly in most parts of the world. And he's been a very important person also in the politics in Croatia. So he's a Croatian representative at UNESCO and OECD. And he's a very effective consultant for leadership, innovation, management, and so on. So I think he has a very good experience what is needed from a modern education. And I'm preparing a lecture for a meeting of Association of Medical Schools in Europe that is dealing with education. So I'm looking forward to hear your proposal. And the floor is yours, so please start your lecture. Thank you.
Thank you very much. I'm really flattered and honored to have an opportunity to share my ideas about education in the disruptive times. I hope you can see my presentation as well as you can hear my voice. Am I right?
We do.
Can
Yes,
you see
we
the
do.
presentation?
Yes, the first page, yes, education in the age
Okay.
of disruption.
Okay, I hope I have still my 30 minutes because we are kind of late. So this was the announcement. And as you already mentioned, my personal experience dealing with the field is I was educated in Croatia, in the United States, where I was a visiting professor for a while. I have spent many years teaching and doing research all over Europe and other countries. So this is where I draw my experience on education from. Also, I was, as you mentioned, engaged in politics. I was a member of Croatian government responsible for science, technology, information technology. Also, I was leading the Alps Adriatic Working Group on Technological Exchange. What I wanted to share with you is my personal view on the issues of education in the disruptive world. First, let me just set a stage for what are we talking about and what is the environment. We live in a very disruptive world, as we can all say on a daily basis. American military experts call it the VACA times. It means that we are surrounded by volatility, uncertainty, complexity, ambiguity, not only in military terms, but also in everyday life and every situation in life terms, which means that continuity around us has been replaced by disruption. And we are gradually accustomed to disruption, but our educational system is really not. I find it interesting that in Zulu, VACA, this abbreviation means to wake up. It's kind of a wake-up call to think about this disruption as a problem. First of all, education is facing challenges of chronic disruptions around us. You probably know a story about cooking a frog. If you put the frog in a very hot water, the animal will jump out. But if you put a frog in a mild water and increase the temperature degree by degree, then the frog will be cooked without noticing. And this is what happened to us the last couple of decades. For example, in 30 years, 50 years time, kids outside the wedlock were an exception. 50 years ago, only 15% of kids were born outside of a married couple in the most liberal country in the world, which was Iceland at the time. Today, it's 70%. Dušan, in your Slovenia, it's above 50%. In Croatia, it's 20%, and we are very conservative. It means that families have lost a lot in 50 years. The same happened to governments. We don't trust governments anymore. 50 years ago, 85% of people on the average would trust governments. Today, it's small two-digit number. We don't trust business people anymore. The trust dropped from 65% to 18% in a couple of decades. The same happened to media. We don't trust media anymore. We see them as sources of fake news and conspiracy theories, and the media are in serious problem. We don't even trust science. It was very obvious during the pandemic that so many people distrust science, so many people distrust science on ecological issues. It dropped from 89% to 65%, which is terrible for science. Also, we don't trust nations and churches anymore. So first of all, these are the issues that education has to deal with. The disruption in the world has become very deep. We can talk about acute disruption to pandemics and the wars, global ecological crisis, all kinds of problems. I don't want to spend time on that, but we are aware that we are living in a very troubled and disruptive world, especially with distorted moral compass. It's harder and harder to say what is good and what is bad today in the situations that surround us. Another disruption is digital disruption. Just look at this picture. 20 years ago, if you could see 6 young people sitting someplace, they would talk to each other. Today, they're sitting and watching their mobile devices. Average teenager spends more than 8 hours per day on his mobile devices, smartphones. 52 minutes on Facebook, 50 minutes on TikTok and stuff like that. At the same time, 9 to 16% of Facebook profiles are fake, which means that we are surrounded by digital nonsense, by a lot of digital pollution, and we believe that many things are true. It's a big problem for education. Another issue that is arising is artificial intelligence and ChatGPT or generic artificial intelligence issues. Today, my students and everybody's students can prepare perfect, even master's degrees, almost PhD degrees using ChatGPT and similar technology. Not many people could recognize that these pieces of scientific work, articles and stuff like that have been compiled by artificial intelligence. So we have more and more problems in dealing with artificial intelligence and its effect on everyday life. I'm right now writing 2 books with the help of artificial intelligence, and I try to find for myself the proper balance between where is my creativity and when and how I can use artificial intelligence. Another disruption, which is all important when we talk about education, is taking place in human side. Let's just take few numbers. 40% of United States of America households have only one member. 70 million singles in European Union. People have become isolated. Friendship recession is enormous. We have hundreds of Facebook friends and we have maybe 1 or 2, in best case, 5, 6 friends in real life. The rise of mental illness and chronic depression is enormous. On the average, my brother is a psychiatrist and he tells me that close to 15% of adults are chronically depressed. Even kids are more and more depressed. We are experiencing radicalization through social networks, as I already mentioned, also stochastic terrorism. 350 to 400 times a year in the United States, there are mass killings in the streets or in shopping malls and stuff like that. And it started to happen even in some other parts of Europe. It happened twice in Serbia a couple of months ago. Increasingly vague gender role. We're no longer sure what gender do we belong to, and young generations avoid sex. So we are surrounded by all kinds of disruptions. Another disruption is motivational disruption. If you read Gallup's State of the Global Workplace report published every year, they basically see workforce around the world, and it was a survey of 142 countries, as people who are engaged only in 13% of cases. 13% of people go to their work engaged, passionately willing to change the world. 63% of global workforce is non-engaged. They just come to work to earn their salary and that's all. 24% are actively disengaged, which means that they come to their workplace to bother others, to create problems and stuff like that. It happened in 2018. In 2023, the new research has a little bit better numbers, but still 23% of people are engaged employees who feel involved, enthusiastic about their work. 62% of employees are not engaged, and 15% are actively disengaged. As I say, they feel miserable at job, actively seeking a new one. And take into account that the same numbers apply to educational institutions, scientific institutions. So we are surrounded by motivational disruption as well. I like to see the problems in education from the point of view of 10 deadly sins. From my personal experience, the first one is that education is not really useful enough. I have been a member of the board in many schools here and abroad, and we always found out that on the average, our students use close to 10% of what they learned during their college and university education, which means that close to 90% of what they learned there, what was the part of curricula, were basically garbage. We can flatter ourselves as university professors that we are doing something great by providing insight into broad areas. But in principle, education today is rather useless if you take into account some economic measures. Most of our topics that our students learn and study are old-fashioned and misplaced. Bureaucracy kills innovation. It happens on a daily basis. We have more and more bureaucratized systems in higher education, in lower levels, not innovation. Education is still based on fear and not love, and it starts from the kindergarten, but it doesn't stop anywhere along the road. Rational and serious, it's a typical description of educational content, but not cool. I like to consider myself a cool professor, and I want to entertain my students, but there are not many people like that, so people basically dislike learning and teaching. Education poorly responds to digital challenges, very slowly and very inadequate. Also, there is lack of creativity and spirituality in educational system. It's too bureaucratized, too based on content, on cramming, and putting things in our heads without really stimulating critical thinking. Too much emphasis on profession, not on passion. Education is kind of cold and uninteresting towards really gaining passionate approach toward life and putting efforts to make science and education really exciting. We emphasize on learning, but not unlearning. I will say about that a little later. Also, learning is separated from work. We have a stupid system that we study for 25 years and then we go to work and then we go to be retired. But the real situation should be that we start learning and we start working when we are able to, and we stop learning and stop working when we are put in the coffins, which means that we are dead. Also, the same problem is with theory and practice. We keep our educational system too theoretical, and we separate it very often from the real life, from practical life and practical life experiences. Change is really needed, not just to curricula, but in principle for culture, because our educational system is similar to the one during the Renaissance. And it's so old and so old-fashioned and so traditional that it's really ridiculous, but we still keep on doing the same thing all over again. Just imagine a doctor coming to a hospital from 100 years ago. He wouldn't or she wouldn't recognize anything. And just imagine a teacher from 100 years ago, he or she would walk the schoolroom and recognize the blackboard and the chalk. She or he may be confused by computers, but he or she would use the same approach and similar attitude as 100 years ago. And of course, to be creative, I have 11th deadly sin of education to add to this list. And this is the biggest sin of them all. There is no real search for a new paradigm. And this is something I don't really understand. How come it happens like that, that we are so in love with traditional institutions and traditional arrangements and departments, and it's all so outdated and so old-fashioned that really presents a huge problem. Here I have used some people whose quotes will be useful. First of all is Noam Chomsky, who used to say that education is a system of imposed ignorance. I don't want to add anything to that. Mark Twain used to say that you should never let education interfere, formal education interfere with real education, which means that educational systems are more of a problem than a solution. It's a miracle that curiosity survives the age of formal education is a famous quote by Albert Einstein. Change is needed, and this change should be really profound. And the best future is the one we create ourselves. And I like to think about mindset change. Whenever something is wrong, I work as a business consultant to many companies, and I try to teach them a very simple lesson. The lesson is based on the story of 5 monkeys. Imagine there are 5 monkeys in a cage and there are bananas very high up, and you want to teach the monkeys a lesson, which means that you give them a step ladder and they can climb and reach for the bananas, but you sprinkle them with icy cold water. And after a while, they don't like the experience, So there is a step ladder and bananas, and no monkey goes there because they hate the cold water. Then you take one monkey out and bring a newcomer. The newcomer doesn't know what was happening in the cage, and the newcomer would like to climb up for the bananas, but everybody will stop him because they don't want to be sprinkled. The new monkey doesn't know why, but very soon he or she will give up. Imagine now you bring another monkey. Now you have 3 original monkeys who are wet and know the story, and 2 monkeys who have never experienced cold water, but if the newcomer tries to reach for bananas, he will be kicked by all the other monkeys. And if you replace all the 5 original monkeys, one after another, by 5 newcomers, they will never even dare to get close to the step ladder, even though there is no icy cold water anymore. And the reason why they are not doing it is because they are afraid of the cold water, and they have a feeling that it's something that should not be done. Why? They don't know. And this is a good description of human culture, our educational culture, company culture, family culture, maybe our academy's culture. All cultures are kind of traditional, and sometimes we do so many things that are stupid, that are not really efficient, that are not proper, but we are accustomed to do it, and we do it out of a habit. So I tell the story about 5 monkeys as a kind of impetus to think about reset. When your computer is not working, you press the reset button. And if our educational system is not working, we must press the reset button, which means that we must do it much better. Why is it so? Because why are monkeys doing that? Because their values, their mindset is such that they don't dare climb for bananas for some kind of fixed idea. Values bring behavior, behavior creates outcomes. And this is something that I would like to share another 15 minutes that I have left from my half an hour to talk about the values that should be really changed and what differences and changes should be introduced into the educational system. Value change is hard. Alan Deutschman wrote a book, Change or Die, and he describes a very simple situation. Imagine I talk to my doctor, and a doctor tells me, if you don't change, you're dead. And he says that I should change my diet, I should, somebody has his microphone on, so it's a source of problems. Please turn your microphone down. Alan Deutschman says, if people are confronted with this idea, if you don't change, you're dead, only 1 out of 6 will change. Only 1 out of 6 will be ready to adopt a new diet, to start exercising, to stop smoking or drinking alcohol, because it's very difficult to change. Inertia is normal. If you ask people about change, they will say, we are all for change, but please change somebody else. Don't change me. I worked as a World Bank expert on change management. I can tell you stories about inability to change. People are unable to change in most cases. Only 1 out of 6 individuals is really open to change, even though we like to flatter ourselves that it's different. Why don't we like change? First of all, we are sick and tired of change. It's called, Americans call it change fatigue. It simply means that change is something that we're tired of because we're surrounded by so much change, which is out of our control. Your change is usually imposed from the top, and we don't like something being imposed on us. Also, change is not explained. Some politicians, some rulers, some decision makers, managers, whoever, they just impose new rules, new sets of ideas without asking people why. And these are the key problems. Now let's go back to education. I see educators on all levels, from kindergarten to university education, as gardeners. They have to develop and nurture 4 types of skills and knowledge. The first one is IQ, so to speak, expertise, professional knowledge. The second one is emotional intelligence, human beings who communicate, who sell stories, who can persuade others. Third type of important set of skills is creative mindsets, teach people to come up with new ideas and innovation. And the fourth one, which is growingly important today, is moral compass. We need to re-educate people to go back to some moral principles that have been abandoned. Just taking into account how much lies surround us. Presidents lie, politicians lie, parliaments lie, everybody lies to us. We don't trust anybody because we're surrounded by a sea of lies and our moral compass is distorted. And now we are going to talk about some cultural changes. One is importance of unlearning. We're accustomed to learn new stuff, but we are not accustomed to unlearn what is bad. I like Zen stories, and I will share with you very briefly Nan-in Zen teacher story. He's visited by an American professor. It was hundreds of years ago. And the American says, I want to learn what Zen is. And Nan-in invites him for a cup of tea. And he makes a tea and starts pouring into his guest's cup. And the cup is filled with tea. Tea is pouring on the table, on the floor. And the American says, the cup is full. You cannot pour anymore. And the Japanese teacher Zen tells him, so is your head. Your head is filled with ideas, prejudices, concepts. Your mindset is set. You cannot learn anything about Zen unless you are ready to empty parts of your cup. So is our head. It's filled with education. This is what Einstein and some other guys think that education does wrong, because it puts in our head some old-fashioned ideas, norms, values, and habits that should be really abandoned. But nobody teaches us how to unlearn. We have to unlearn. I have seen that as a digital expert, so to speak, when we had to introduce new digital technology someplace. The key problem was to enable people to unlearn old ways of doing stuff and learn the new ways, and people are so hard in unlearning. We have to introduce unlearning into our educational system, which means that we have to teach people how to get rid of all the old-fashioned and ideas that don't work anymore. There is a story about that, another Zen teacher, but I will skip this story for time purposes. You can read it or Google it. Mark Twain used to say that the best education you can get is when you unlearn what you have learned. And this is exactly my point. In real life, we have to readjust our mindset very often to things that are much better developed and much better recognized in the real life than in our educational system. You see, I'm very critical about it because I believe that it can be much better. Of course, it has many qualities and values. I'm not talking about that. I'm just talking about the essential need to improve it. Another issue that is important in our educational system and the set of values is culture of candor and transparency. We keep talking about that, but we are not doing much, starting from our politicians. I have learned from my consulting experience that the best way to deal with any problem is talking about it with confronting the brutal truth. You have to put all the facts on the table. This is why I so sincerely and openly discuss these issues, because as Jack Welch, I had a chance to meet him. He was proclaimed to be manager of the 20th century. I was his host when he visited Europe. He used to say that lack of candor is the dirtiest little secret of failure in business. I would say that lack of candor is a secret of lack of success in anything we do in life. So we have to go back to the truth, candor, and transparency. We need culture of proactivity. We don't teach young generations to be proactive. We teach them to adjust, to accommodate. I have stories here again, but we don't have time for that. Nobunaga is a Japanese warrior. But let me just say that as a consultant, I try to teach people that there are no problems, there are just challenges. So whatever you do, confront the challenge. And I teach my students and I teach my kids, I have 4 of them, that they never fail. There is no failure in life. You either win or learn. Whatever we think is a failure or lack of success or defeat is basically a learning process. Of course, we need culture of patience and persistence. We live in a world that is not patient and persistent anymore. I will skip this because time is really running fast. Charles Kettering used to say that an innovator is a person who does not take his education too seriously. Another quote that I really like. Kaizen culture. Right now, I'm a consultant to a set of managers from Toyota. And one of their key principles is Kaizen. Kaizen means that it's good but can be better. We have to teach people Kaizen culture. We teach people it's bad but must be better. We must teach people it's good but can be better. I have learned from my consulting experience that when you talk about problems and you mention negative aspects of problems, then everybody gets nervous. But when you talk about improvements and you say, okay, you did it right, but it can be better, then you can really initiate problems, because change is in principle good. We need culture of encouragement. We have to try to catch people in what they do right. Our educational system, our business environment, even our family, everything is oriented to catch people in what they do wrong. And then we correct them. Then we try to make them not to make these mistakes, but much better culture that creates new improved education and new improved work is catch me in what I do right. That's why I talk to my students when they ask me what kind of PhD study or thesis I want or seminar work. I say, only the sky is the limit. Sweep me off my feet, blow my mind, make it so I fall off my chair. Do something great. And they usually do. I could talk for hours about their accomplishments, but we don't have time. Another culture that we need to introduce is diversification culture. We have introduced in our educational system some kind of good grades for everybody. I learned from Jack Welch that 20% of people are stars. They are excellent. In our schools, there are 50% of excellent students, sometimes 60, 70%. It's stupid. We need a Gaussian approach, because there is a small number of excellent, there is a small number of very bad, and many people are in between. The greatest injustice is to be equal to the different. I want to spend most time with my best students, and I spend most time with my bad students, because the system supports average, the system supports bad and below the average results. We don't want mediocrity. We need meritocracy and excellence. One of the ideas that I really like very much comes from Fyodor Mikhailovich Dostoevsky. He used to say that too much tolerance harms the intelligent. Basically, he said that tolerance will reach such a level that intelligent people will be banned from speaking and thinking so as not to offend the imbeciles. And when I watch politics, and I was in politics, and when I watch everyday life, very often it reminds me of Dostoevsky, because we're surrounded by so much stupidity coming from very high levels of people describing our work. Another important culture is culture of self-confidence. We need to teach new generations to be self-confident, because it's the key of success. And we cannot teach them self-confidence if we are harsh and negative when we follow their success and their climbing through the educational system. Self-confident people are not afraid of changes and challenges. And since many people around us are afraid of changes and challenges, it's because they are not self-confident enough. This is a thing that I will skip again. And the last thing, maybe I have still time to talk about if I want to stick to my half hour, is win-win culture. What we need to introduce into our educational system is ability to win together. But it needs really a completely different attitude. Our attitude is win-lose attitude. We look at the world in business, in politics, in education, and real life everywhere as a win-lose game. For example, let me just explain this. It's an important principle. Imagine my wife and I tomorrow have to decide, because it's Saturday, how to spend Saturday evening. For example, I would like to go to a restaurant and eat some nice dinner, and she would like to spend the evening dancing. If I win, we go to a restaurant, she will be hurt, which means that she will keep telling me, oh, we are now sitting here as lazy people, and we are eating calories, and we could have kicked the stress out of our bodies by dancing. And what if she wins and we go dancing? Then I will probably spoil the evening by saying, it's so loud here, people are stepping on my toes, we could have been in a restaurant. So whenever one of us wins, it's basically a losing game for both of us. we have to develop an attitude of win-win. What it means is a simple sentence. You must be ready to give up on your idea. I will be ready to give up on mine. And we will search for an idea that is better than both mine and yours. I don't want to win and you to lose, and you don't want to win and I to lose. Let's discuss how to win together. We have to incorporate that into our educational system and into our everyday life, into everything we do. Because if we don't teach people win-win culture, we are going to continue living in a disrupted world. I have so many things to share with you on this topic, but let's just add 2 more points. One is 10 key future skills belong to art of humanness. We have to build humanness. The other, navigating the new world. We have to teach people transdisciplinarity, new media literacy, cross-cultural competence, virtual collaboration. And the third set of ideas must be dedicated to artificial intelligence, working with bots. We must develop understanding of digital world, cognitive management, and stuff like that. And my last idea shared with you is another idea by Alexandre Dumas. He said, why are kids so smart and adults so stupid? It must be education that does. Of course, just let me add one concluding sentence. I have prepared this presentation in half an hour. Usually talk about this 1.5 hours, maybe 2 hours, with a lot of detail and with many specific preparations and projects and suggestions. And I have been introduced in several small and bigger reforms of educational systems on different levels. But if you take anything away from what I have said today, it may be jokes and quotes, but maybe serious stuff: 10 deadly sins of education, story of 5 monkeys and what is the problem, how to reset, and of course, Kaizen. It's good, but can be better, which means that we have to make it better one way or another. Thank you for your attention, and I hope I haven't passed my time limit.
Thank you very much. It was a very, very interesting lecture. Because I will have to leave just before 7, maybe I can contact you and have some discussion with you, because it's really very interesting and important for education. And now, Violeta, please introduce the next speaker. I will stay with you for a while, but unfortunately, I have to go then.
Thank you so much. You know, I am egoistic, and I asked Velimir to remain with us, but he has a big problem tonight. And Velimir, I would like to ask you first, thank you very much. And I would like to ask you, is it possible that you remain, or you have to go? If you have to go, maybe we will make now some question for you.
I promised to stay because it would be impolite not to stay, but my problem is a memorial for a close friend.
I know. So I would like now to ask you permission to make now a little short discussion. We have also the reason that Dušan has to go also. I would like to mention that our member Wolfgang Masnak, who came also several times to us, take me the attention what important is to have the discussion, profound communication between us. So please, Dušan, I would like to invite you to participate with a discussion, with a comment for VELIMIR SRIČA.
Yeah, as I said, it's very interesting presentation, and soon I will have a talk in Greece about artificial intelligence and teaching and so on. And I had a kind of reflection that artificial intelligence should be used only by intelligent people. Because really, there's a danger how it can be misused. There are many promises of how new technology will help and improve our lives, but so far, technology improved the life in one way and somehow made it worse in another way. It's like yin-yang, you know, you are talking about Ken-Zen, but yin-yang is also important. And I think that we have to make in education people aware of what would be the consequences of their actions. And I think that's completely missing in education, or mostly missing. What's your opinion about that?
Thank you for the question. That's one of the most important questions and issues, I think. I always used to say to my students that technology is a magical wand if it's used properly, and technology is a very bad help if it's not used properly. It's exactly like you're saying. Artificial intelligence is for intelligent people. But, you know, if there is a possibility for a technology to be misused, it will be misused, and we must not have ideals about that. And we have to teach, you know, the problems from my point of view. Many people look at artificial intelligence as a competition to humans. I see it as a supplement to humans, and I try to teach myself and teach everybody who listens to me, so to speak, that artificial intelligence is a great help when we use it properly. And it's basically our efficient personal assistant. I do everything today with ChatGPT. If I have any problem, or with Copilot, if I have any problem, I ask a question. But then I think about the answer that was provided by artificial intelligence, because the answers sometimes are great, sometimes very bad. And if I don't have a proper judgment, and if I don't know how artificial intelligence really works, how it was trained by somebody, and how many prejudices and misconceptions have been built into its infrastructure, then I'm in a real trouble. It's like social networks. There are great things with social networks, but it's a major source of problems in the modern world because we didn't control it from the very beginning. The same with artificial intelligence. The same with internet. Internet started on the wrong foot because it was anonymous from the start. And it's stupid because in any system, you must never be anonymous, because then you can talk nonsense, then you can hide yourself, then you can do all kinds of stupid things. The same with artificial intelligence, social networks, and stuff like that.
Oh, thank you.
Thank you so much. If nobody would like to comment also, I'm very happy. Thank you very much, Velimir.
There is a hand raised here.
There is a hand, okay. Please.
Yes, Dušan Marko Turk, Vice Dean of the first class. I must apologize because my camera is not working and I cannot fix the problem now. So, but very interesting conference you have, Professor SRIČA, of this lack of trust, of decay of a civilization, and there's a logical question that arises from that. Why does those who are responsible for the society, global responsibility for the society in which all these phenomena occurs, why they do not take any measures, any steps? That's a political issue, I mean. And there's also, I would agree that if there's no change, then the Western civilization should perish.
Yeah, that's a good point, and I don't want to misuse too much of the time, but I would say from my political experience, because I have dedicated 5.5 years to politics, I was independent and volunteer in politics, and it ended with a book titled That Disgusting Politics. And it reflects my attitude towards politics and politicians. In principle, today, all over the world, we have negative selection in political life.
Yeah.
In my experience, 10% of politicians are idealists who want to change the world. And 90% of politicians are political animals who are there for power, for personal benefit and stuff like that. And they organize very nicely, and they control the system. And of course, they don't want the change that is not to their liking. And when we talk about principles, they don't really like principles. They like something else. Very brief answer to a very complex question. I have written a whole book about that, and the book is very detailed. One of the reasons is that kind of negative selection. Today, decent people avoid politics, and of course, then the majority of people in politics are in discipline.
Thank you very much.
You're welcome.
Thank you very much, VELIMIR SRIĆA. We remain in contact and we hope to come again. You can come again. May now I invite...
Am I excused now? Can I leave?
What?
Yes, yes, you can. You can.
Okay, thank you very much for your...
Thank you. That's why I told you that. And excuse me that I try to maintain you, and I think it's very important that you have to go now. Thank you very much.
Thank you.
Thank you for staying.
Very much.
Bye-bye.
Thank you. Bye-bye, Dušan. See you next time also again.
Yeah, I will stay for 5 minutes more, but then I have
wonderful.
to go.
Wonderful.
Yeah, the elections will start. Oh, no, I stay 2 minutes. Okay.
Oh, okay. Thank you, Dušan.
Thank
And now I would like to invite Anastasios Bountis. We call him also Tassos Bountis. I would like to tell you that he just received a very important prize. He was selected as a recipient of the prestigious 2024 Zaslavsky Award for Outstanding Scholars in Non-Linear Physical Science, presented annually by the International Non-Linear Science and Complexity Conference Series. Tassos Bountis is a distinguished Greek mathematician and physicist, currently Professor Emeritus at the University of Patras in Greece. His research expertise spans nonlinear dynamics, chaos theory, fractals, and complex systems, with applications in physics, engineering, and biomedical sciences. Over his career, Bountis has published extensively, including 168 peer-reviewed papers and several books. He earned his PhD in physics from the University of Rochester in 1978, and after which he held teaching and research positions in Caltech and Carcassonne University before returning to Greece, to his country. In addition to his academic roles, he has directed the Center for Research and Applications of Nonlinear Systems at the University of Patras and played a key role in organizing numerous international conferences and summer schools on nonlinear science. Tassos, please, you have now the floor. Suppose you have to unmute yourself. Tassos?
Okay. I hope you can hear me now. Thank you very much, Violeta, for this very, very, how to say, exaggerated introduction. I greet everybody. I'm very honored that so many fellow members of the Academy and friends are here to listen to this presentation. This is something that I have already presented. There was in a recent education activity of the Academy where Yannis Liridzis and Violeta Dinescu and also other scientists appear because it does have a lot to do with bringing together different aspects of education that I believe will be very useful to our children, to younger people, to perhaps overcome some of the difficulties that the previous speaker outlined about education. Even though my approach also is a yin and yang approach, again, as art and science are sometimes viewed as opposites, and well, but in our approach, I believe all of you, they are not opposite. They are can be seen, can be viewed together. So I would like to follow me in this educational, more or less, approach of how I see art imitating life, or science imitating art. The surprise we get often by looking around us, either underneath the earth or higher up in the sky, and we see pictures real, actual physical situations which nature has produced, and they look to us quite artistic, quite interesting. But why? Why is this artistic? One might say that it's complex. So if I see something complex, like the stalactites and the stalagmites in a cave, does that really unravel or reveal some secret about it? Is complexity beautiful? Is there complexity in the sky? I'm often surprised when people look up at the sky and say, what a beautiful picture. All the stars that we see, the millions of stars, they bring us so many ideas about the universe in mind. But is it beautiful? Well, I don't know, some artists have thought so. And have even been inspired by its beauty. So what is the relation between art and science in this view? Is there a place for complexity or for nonlinear science, as you heard before, to analyze something that is so beautiful? First of all, we have to think about nature. And the way I will approach it is to first have a mathematics approach that will have to do with fractal geometry, and we'll look at some fractal analysis of paintings where mathematics and beauty come together. And one is used to perhaps understand the other more. But you might argue, how can that be possible? Well, you might disagree. But it then never hurts to bring two concepts together when you see that there are certain correlations between them. Now, when we go to physics, I can also think, as other scientists have done, whose work I will discuss here also, is can there be physical concepts like complexity or entropy? Can they add something to our understanding and appreciation of art over many years? So let's see how this can be done. I would like to follow a more educational approach, as after the previous speaker, and I would like to ask, from a child's point of view, what is it that impresses us about looking at a tree? Or what is it that we admire when we look at the structure of its leaves? Well, it's not so actually strange to come up with some conclusion to understand this complexity. Richard Feynman once said, what I cannot create, I do not understand. So I think our educational approach to our children, to our students today, should also be, let us construct something that you think is beautiful, that you think it's complex. Can you make it in the laboratory, so to speak? Well, I think we can, because if we observe in these pictures that you just saw, and also I have mimicked them here in this design, there is a certain kind of self-similarity in the way the branches develop out into a complicated evolution, which somewhere has to stop. So to stop somewhere, this increase of the lengths of the branches must be done following a certain scale. So I will take this scale to be 1/2. Every time I will follow a branch to its smaller, not only, as you see here, the length, but also the width of the branches follow a certain scaling law by powers of a number that is less than 1. So let's say the number is 1/2, and we take every branch and we halve it. Yes, we will see that we get a finite structure out of it. So then I will ask you, I will ask a student to work out this exercise. Shorten the branches by 1/2 at every bifurcation, and also rotate them by 45 degrees on both sides, and all of a sudden you see something that looks a little bit ridiculous, but it does have some essence of what we just observed of the complexity of a tree. So we simplified a little bit the complexity of a tree into something that gives us an idea of what it stands for. Now, how can we make this mathematical approach more sophisticated? And if we call this complexity in the final picture of the foliages and the tree? Well, yes, there is a theory of the fractals that actually is not only a theory now, it's in practice, it has been used and applied in many, many areas of science, even in creation of movies nowadays, as you all know. But the idea for a child or for a student is to understand that you can play a game by reducing the size, replacing something similar, very simple like a straight line, by another shape that's a little more complicated, by just changing the scale. And as you keep going, you change the scale to 1/9, then to 1/27th, and all of a sudden, what you started from is now looks like a convoluted, and in fact, it's an infinitely long coastline that you have created. So how can I fit a finite object in finite space, something that's infinitely long? Well, the answer is that you have to really increase the dimension. So this is not a one-dimensional object, and it's of course not a two-dimensional one because it doesn't cover the plane. And it turns out that it has an integer dimension that is that's non-integer and that it's between 1 and 2. What have we done? We have managed to include an infinite amount of information in a very short space. Now I'll become more sophisticated and use these ideas of fractals to make actual transformations. But what transformations? I will begin with an initial design. It can be a parallelogram, or you can change it to an ellipse or some other object, but it is there, capital L. And I will substitute this by 4 smaller copies, scaled down by several numbers as I do this, which I will keep the same at every step of the iteration. And as you see here, the one object became 4. There is one that I call 1, which looks like the above, it's smaller. Then there's 2 and 3, which are smaller by some scaling, as we used before, the 1/2 scaling idea with the tree. And then there's a 4th one here, which is a very thin parallelogram, and it's the stem. And I will take this, so to speak, prototype, and I will repeat it. I will repeat now this procedure for every single one of the parallelograms you see below. I will do it again and again and again. And before you know it, after a few hundred iterations, but it takes just a few minutes time, you see something that surprises you. Now we are closer to something that we might call natural and complex object. And what we have done is we have constructed the famous Barnsley's fern leaf, and by just repeatedly performing the above transformation. Now, which child cannot do this? I don't know. Which teacher cannot teach it? So this is what we should be doing in our education, in classes, bringing our young people into contact with the fact that, yes, they can reproduce nature by using some simple scaling mathematical ideas. Is there anything beautiful about this? Well, apparently some artists thought so. So in a paper not long ago, some physicists and mathematicians claimed that many paintings of the great American painter Jackson Pollock, that all of you have heard about, who did something incredible in the years from 1943 to 1953 or so. He produced a series of paintings that really charmed the whole world. And they became representative of American painting at the time. These paintings have a complexity. You can look at it and you find self-similarity, certain, or sometimes I think most of you always are doing this. Looking at this picture and you notice a part of it, it's similar to another part in a smaller dimension. So can it be that we can find out a dimensional value, something to identify these pictures and say that this can be related to somebody like Pollock did? And in order to find out, we decided with some colleagues of mine to actually do it ourselves in a very pedagogical and simple-minded way. But this time we took another painter, Piet Mondrian, who at the earlier century, 20th century, was actually painting very, very nice physically looking objects. He later on went on to to paint a lot more abstract and simple-minded geometrical pictures. But before he did that, he showed this, and it seemed to us that there is something like a complexity in the branches of the trees. And we decided to go and find out. What do we do? Something a student will do. We divided the pictures in small grids and with little squares. And the squares have to be taken smaller and smaller at times, because the total mass or area of the system must be constant. You can use more squares with a smaller length size, and then more squares with smaller length size, but they all must have the same dimension d. So in order to take an idea, what kind of dimension would this very, very tricky and complicated picture will have? And indeed, when we did this simple measurements, we found out a dimension between 1.7 and 1.8. But that was the first step. We then decided to become a little more sophisticated. And we used an optimization approach, linear regression, to actually extend this to more and more enlargements of the picture, magnifications. And if we were able to do this, then what would we find? We found that for both paintings, actually, the slope of the line, which gives the dimension, is 1.7, while we had said 1.8. Now, I think that was interesting, and that allowed us to understand a little more about the complexity of paintings. But now I would like to talk to you about another aspect of studying complexity, and that is through physical quantities. Now, physical quantities, where complexity also arises now as a physical quantity, even won the Nobel Prize in physics a few years ago. So complexity is a physical aspect, and entropy, of course, which measures the amount of disorder, as we all know. Could we use these concepts of physics to start to understand a little more pictures, paintings, artistic designs that we have seen in the past? If something is regular, it is expected to have small entropy values. The more disordered it is, and less regularity, such as Pollock's paintings. And otherwise, such images with less regularity will have a more disorder and larger values of the entropy. Then there is another concept of complexity, which some scientists actually introduced it as a structural magnitude, which is 0 for extremes of order and disorder in the pixel arrangement, but becomes positive when one starts to concentrate on more complex spatial patterns. The joint use of these two values offer useful information on a complexity entropy plane. Well, this is what some of my colleagues discovered, and some of them are also members, like Matthias Perk, members of the European Academy of Sciences and Arts. And some of them also presented the work earlier. I was very, very surprised and impressed by what they were able to discover. And this is something I would like to share with you today and see whether their work, which is impressive, is really useful or revealing or worthwhile. Let's see what you think. We can discuss it perhaps afterwards. So what these guys did is not look at one or two paintings and study their complexity, if they have fractal structures and so on, but they did something a lot more, I'd say, majestic. They studied thousands of artists and hundreds of different styles and over many, many years. And the way they did it was to divide paintings into smaller, a matrix of very, very small squares, if you like. And they used values of how much red, green, and blue there was in that square. So they were able to calculate two physical measures that I mentioned to you before, the so-called normalized permutation entropy. And in fact, to help people who might be interested, I would be happy to send you this, and so you can actually go to the literature and find out more details about the people who worked this out in the literature. And now the other statistical complexity also depends on entropy in some way, but it is a quantity in its own right. And this is the amazing thing they discovered. To me, it was really unexpected. And I don't know what you will think about it, but indeed, in complexity and entropy plane, whatever they are, these people were able, or were able to discover that there are artistic styles which can be grouped together. By what measure, you might say? Well, the measure here is physical. They say that the artistic styles you see here, which involve Northern Renaissance, early Renaissance, realism, art, academicism, expressionism go here, romanticism, Art Nouveau, all the things you know about from somewhere in history, we will see about that, they are falling together in the same part of the plane, which means they share the same complexity. The complexity may be low, but it is the one you see here. And there is, if you want to find, but entropy is high because there is a disorder here. The complexity is low because there were pictures of ladies and portraits and landscapes, but there was order, but complexity was low, but the entropy was higher here because there were a lot more things happening in those paintings. And what happens if you look up here to the left, where entropy is very low, but complexity is high, you find that more modern styles like concretism, minimalism, color field painting, post-minimalism, conceptual art are really standing by themselves, away from the others. So one might argue that these physical concepts of complexity and entropy are shedding some light into art of painting, of course, over the years, and the way styles evolved, and the styles, independent of the time they were found, they could be grouped together. And the final slide that also really impressed me very much is the fact that here the authors grouped together artistic paintings by the year. So whatever we call the Renaissance, Neoclassicism, Romanticism, now it's grouped to see when did they occur. And we see that we can group together these items from the years 1760 and all the way to 1760 to 1836. Interestingly enough, in modern art, there are the years that Mondrian and Pollock worked out the paintings that you saw before. Mondrian was, here was Pollock, 1939 to 1952, that was Pollock. And Mondrian was here, 1902 to 1909, which is the paintings that you saw before. So that brought them together under this group. Yeah. I think this is interesting food for thought and ideas to understand art, if you like, the art of painting, all in a more global way, making use of all these tools that mathematics produces and physics produces, but I think they're not just only for physics and mathematics, they can also be used to give us some new ideas, a new way to appreciate art and the history of art. So this to me raises a certain number of questions. First of all, we saw complexity in the earlier picture I showed you today, and I'm sure that some of us would be tempted to say, oh, it's beautiful. The complexity of a tree or the caves with the stalactites, the stalagmites, or the star formations in the sky, well, that's beautiful. Why is it beautiful? I don't think you will get a straight answer. They don't know. So this is what I would think it is an inherent beauty in the work of art. But can we go any deeper? Can we understand it better? Well, it turns out that we could at least use some physical concepts like complexity and entropy to classify different artistic styles over the centuries and view them, if you like, in a more global way. Is that allowed? Would that be a heresy, or would it be something constructive in our work as scientists to make this bridge between art and science? And that brings me to my third question. Do we accept these concepts of mathematics and their use to study art? And if that's the case, then why not sculpture or music, for example? Would such ideas be interesting and reveal something important about these arts? I want to thank you very much for your attention, and that's all I had to tell you today.
Thank you very much, Bountis. It is really a wonderful lecture. And your last phrase here, can we visit?
I must stop screen sharing. Yes, please? I must stop screen sharing. No. Stop sharing. Yes.
Okay. So your last mention that it is possible to understand music and arts from this point of view. We just have now researching about the composer Aurel Stroie, who worked in this way. So thank you very much. I would like to ask you, Ioannis, I suppose you would like to say something for Tassos Bountis? Unmute you. Ioannis.
Okay, can you hear me?
Okay.
Yes, both of the speakers were excellent and different tonight, and I would like also to say something for the previous one, but he's not here. But I would like now to very much to congratulate my friend Tassos, and which has triggered me, not only now, but in the past, since I have met Tassos about how he's thinking, in the field of complexity, in the art and life. So what has triggered me mostly, it is the title that art imitates life. So if I could take a couple of minutes, Violeta and dear colleagues, to say that it reminds me the mimesis for Plato, which is imitation. So it was used by Plato and Aristotle in ancient Greece, as you know, to discuss the creation of art, which represents nature. I'm not going to go into the detail of complexity, which was excellently presented, but probably in the first part of the title, which has to do with what imitates which imitates what. So the phrase used today is art imitates life, but Plato and Aristotle both stated that it is a universal trait of humans to want to express via art, what is in their everyday environment. Both, and Plato and Aristotle, as far as I remember, acknowledged that art was an imitation, a representation. However, there are limitations to what the artist can do, of course. So regarding the degree of sensitivity and susceptibility of each of our five senses, including intuition, I could say, then how sharp they are and what coupling is achieved with the brain neurons in the cerebrum varies between people and hence between artists. It recalls the Aristophanes' famous question about the comedies written by Menander, when he says, "Oh, Menander and life, which of you took the other as your model?" So it reminds me the question, the hen made the egg or the egg made the hen? I have read, in literature, Oscar Wilde, George Bernard Shaw, have spoken about this, in an idealistic or romanticized way. But the idea of life imitating the art is a philosophical position or observation about how real behaviors or real events sometimes, or even commonly, resemble or feel inspired by works of fiction and art. So the phrase today's talk may be considered synonymous with anti-mimesis, the life imitates art. The direct opposite of Aristotelian mimesis, of course, which is art imitating the essence of life, as Tassos has very nicely presented in a physical way. So in any case, if I had to express my stand on this excellent conception of Tassos, Professor Boutis, I would dare to say that people and artists of various types of art tend to be aesthetically effective, that the feelings expressed must reflect more than the personal idiosyncrasies of the artist. So it's just a thesis. My thesis is to comprehend the inner and intimate implication of this symbolic language used by ancient philosophers and alchemists, in Middle Ages, in search of the truth. So indeed, art in its myriad forms serves as a mirror reflecting the complexities of the human condition, in this intricate dance between art and life. So I have so many, immediately, spontaneously come to my mind. So I wouldn't like to take your time, but I'm very enthusiastic.
My statement, of course, Yanis, was that
I would like to stop here.
My statement was art imitates life. I don't want to
exactly.
Quote Oscar Wilde. I
wouldn't dare
to do that.
You gave me
life imitates art. No,
thank you. Yes, you gave me trigger, to say,
I said something simple.
To dig inside, more inside deeply, in the abstraction, in the symbolism and the metaphor. Thank you very much, Tassos. I'm very glad, that you gave.
Thank you, Ioannis. Thank you so much.
Thank you very much.
Thank you.
Thank you. I see that Klaus Mainzer, our president, would like to say something. Klaus?
Yeah. I'm unmuted. Yeah, good. I have a very simple but perhaps a fundamental question.
That's the one I'm afraid of.
To the physicist. You spoke about complexity. Complexity is an amazing word and a lot of fog and in the past. But there is a precise concept in physics on complexity, and you spoke exactly about that. And that is dynamical complexity related to dynamical systems. That means pattern formation in phase transition. The pattern may be in equilibrium, then periodic, quasi-aperiodic, and finally chaotic, things like that. And that can be measured. But nowadays in science, there is another amazing and very important concept of complexity in science, and that is in computer science. Complexity in the sense of problems may be so complex that they cannot be computed, or we measure complexity of the programs, for example, by computational time. So my question is, what in your opinion is the relation between computational complexity and physical complexity?
Oh, Klaus, I think this is a very, very important question, and it is not so difficult to answer. I would say that, yes, computer scientists were a little offended some decades ago when they saw that we physicists and mathematicians were using the concept of complexity. They said, wait a minute, this is our concept, our idea. We speak about complex algorithms. And indeed, in computer science, the meaning of complexity is very precise. It is speaking about the length of an algorithm in order to reach a certain very specific goal. So yes, I would not say that it is so complex, but they mean something very precise. The concept of complexity, however, as you said, Klaus, entering the field of physics and mathematics and as a complexity science, it started in the last 20 years to assume a certain self-respect and some recognition, especially when we speak about the climate and the ability of very, very powerful algorithms to predict the climate. So to follow your question is that computer scientists go as far as creating the algorithm. That's what they're interested in. That's what they do very well. And it can be very well, in their own definition, a complex algorithm. We come in and say, what do we do with this complex algorithm now? Can we use it to study a phenomenon as wide and as powerful as climate change in a certain region of the world? And the idea is that, yes, we can. By now, we start to be a little bit very daring, I would say, to be able to say something about matters we wouldn't dare speak about before.
Mm-hmm. Yeah, in the background concerning our discussion here, I have already relation to arts. And I thought this kind of computational complexity is more close to music, because pattern formation in physics, you show us all these nice structures and even analyze the relation to painting. That is obvious and very impressive, but I think in music, because it is such as an algorithm developing in time and computational time. So it may be this kind of computational complexity very interesting for the relation to music. There are more or less minimal music. I think there's even that term in arts. And then there are very complex structures which are developed, for example, Bach and so on. And even in modern contemporary music, very complex structures, but sometimes simple one. Anyway, maybe that is a nice measure to compare these different directions also in music.
It's an incredible subject, but I would say this could be the difference between an inspired complexity music and non-inspired computers music. A non-inspired computation would be complexity, and an inspired one would be the other one, because there is a dimension of mystery, a dimension of it's my opinion, but it's a beginning of a big discussion. Now I see Peter Hermann and Wolfgang Mastnak. Tassos, is it who would like to react, or may I invite Peter Hermann and Wolfgang Mastnak?
Right, of course, they will follow me, but I just wanted to say that the computational complexity is a very specific idea. It can be described very simply by what it is, by the length of an algorithm. The complexity we see in science, the science of complexity, is a lot more versatile. It's a lot more, I would say, I don't want to say the word complex, but deep in the sense that it uses
ontological.
Yes, and a lot of different scientific ideas enter into the concept of complexity. Whereas the one for computers is very, very simple to understand. So, for example, can you tell me from Bach until Yannis Xenakis, how has complex music evolved? And how can we measure, even dare to say measure, something that will tell me why Yannis Xenakis is a more advanced stage from Emanuel Bach?
Wow, it's a question, big question. Oh, thank you, Tassos. May I invite now? I don't know who was the first one, but let's try. Let's begin with Peter Hermann. Please, Peter.
Yeah, well, I would like to add one question. I really enjoyed this last lecture, and the three questions you mentioned at the end. I would like to add a question: is it possible, and if it's possible at all, in which way can we go the other way around? Meaning looking at complex mathematical, arithmetical formula, and develop from there what is called arts, what is called presentation, not in terms of was it the 11th or the 10th symphony of Beethoven, simply as that, but looking really at the inherent beauty of mathematical formula or physical experience, and looking at this and presenting it in a different way. And then in addition to this, you talked about this way of complexity. I had been teaching once economics and painting, and I think today actually I saw migrating birds, 6 or 7 on one, nearly on one spot, migrating, flying to I don't know where, strangely enough to the north, but to see the beauty there and look at the beauty, the different aspects of biology, of chemistry, of the different areas of science, and then the different areas of arts, which is the beauty of nature as well, and the beauty of music and sculptures and books.
Thank you, Peter. Thank you, Dr. Herman. Yeah, but on your first point, I would say that if somebody wanted to write a thesis or concentrate further on this topic, I would go and see how Yanis Xenakis, who actually made formal use of mathematics, how did he use mathematics in order to make his music more developed, give it more depth and more that he is not able to tell us today. But people who studied Yanis Xenakis should start from there, and then go back to Bach and see that there are some mathematical patterns that do repeat in Bach's cantatas. So there's a lot to say that, but the motion of the birds in the sky has been to a large extent understood by the ideas of complexity and physics today. And also Parisi, who was one of the Nobel laureates, was very famous in studying that.
Wonderful. Thank you so much. So Wolfgang Mastnak, he is the one who told us how important it is, exactly this part of the presentations, the discussions.
Yeah, thank you, Tassis, very much indeed. And my question is whether you think we need a sort of aesthetic revolution in education. My question has a background. For example, in China, we have Meiyu. Meiyu is translated as aesthetic education, 美学美感, and 教育. One perspective we are working about in China is how to tackle the huge problem of mental health issues in the younger generation by aesthetic education. On the other hand, for example, the International Journal of Aesthetic Education plans for next year an issue how aesthetic education might help to solve the complex problems of today's world. So I think those questions have a lot to do with what you explained and what the first presentation explained. So my question to you, do you think that an aesthetic revolution in education could help to tackle the problems, the complex problems and the diverse problems of today's world?
Yes, absolutely. It's a very, very important comment, and it goes way beyond what I spoke about today, because I think that young children today do not know how to adopt certain values. They, as the previous speaker actually outlined, we all know ideas of what is beautiful and whether beauty and art have anything that transcends time and space, that it is actually absolute in a way, as we say, this is beautiful and that is beautiful. Can we actually make this a program for education for young children to see what they think? We start from there with a simple question. What can the children in elementary school tell you about beauty? And what do they think is beautiful and what do they think is ugly? Then the teacher will start to collect ideas from all the kids and begin to formulate certain conclusions. But you're absolutely right that such simple ideas are not pursued, I'm afraid, today in lower education.
Thank you so much. It is the beginning of a very interesting idea to discuss further and further. It's very near to our thoughts, and it's very near to artistic
And the
way.
activities, yes,
Right.
the STEMAC
Yeah.
activities.
Exactly.
Should be actually pursued further in the future, more actively, more vividly.
And it is a definition also of the activity of the academy, sciences and arts, how to understand this correspondence. And this is a very important thing. It's just what you said about what is the difference between the complexity by Bach and complexity by Xenakis. And we discover that sometimes less means more regarding complexity also.
Yes.
I would like to discover if there is somebody who would like also to make another comment or a question, another comment.
Do you all remember the movie The Dead Poets Society with was it Robin Williams, and in which the teacher takes the book where there is a graphical presentation of the beauty of a poem plotted out on an XY plane, why this poem is beautiful, and he took it and tore the page off the book. It is an attitude that is well understood. No, you cannot just use scales and say this work of art is worth more in terms of inspiration and beauty than the other work of art. You cannot count things. That's why I was so careful to state what I said today, not to make you all angry that I am really advocating that this is what we should do with art. Of course not. But it's a way to bring these two cultures together, the scientific and the artistic one. That's all.
Anyway, in music, the composers today are very interested in how to, the balance between order and disorder and process between, and how to transform a continuous transformation. And you may also, the way you discovered communication between different part of time, and it is possible to discover communication between music composed in 16th century with the music from today, from special point of view. Very interesting. It's like a new method of understanding arts, and because I have to do with music, I really appreciate this way of understanding and analyzing music of all kinds of styles and all kinds of times.
Thank you very much.
Thank you so much.
I hope we have more discussions like this in the future meetings.
Yeah, it is so important, and you know, it is important to think about and to continue to discover new ways of understanding old things.
Very good.
Thank you so much, and I would like to excuse that I came in the last minute because I had the problem. I didn't know what happened, but the next time I shall be there. Thank you so much for coming. And I would like now to ask Klaus Meinzer we have now to
conclude.
Now,
to conclude, yeah.
Okay.
Thank you.
Now I must spontaneously react. I think the essential point was discussed and highlighted this evening, namely the connection between creativity and complexity with respect to STEMAC. You know, STEMAC is our one of our great projects in the academy. But spontaneously, I like to end with Einstein. To make a long story short, you know, Einstein was always to the point, and he said, "Keep it simple, but not too simple."
Not too simple. Very true. Very true.
Very good. Thank you so much. And I hope we meet again, and we concentrate on this part of the discussion. As I told you, repeat again, Wolfgang Mastrak told me it is so important to tell you also, because this part of the discussions means also the beginning of other collaborations.
And also, we will send you our slides, Violeta. I will send you my slides. So if anybody is interested, one can take it in a PDF file and you can see my talk if you are interested.
Thank you very much. I already received in the chat a question to ask such thing. Thank you very much if you do this. And
Violeta, sorry, I would like
maybe
to.
Velimir should do that. Velimir should do that also.
Yeah.
I would like
Ioannis?
I would like to make a request for Tassos, if possible, to write this nice talk that has been also repeated in the past in our journal, EASA, as a review.
That's right.
And,
Yes.
I think it's an excellent presentation. So Tassos, if you have some time, with pleasure we can accommodate in our EASA journal.
Very good. We'll talk about that. Yeah,
It helps also the education, the students or other in master's degree or PhDs, or other graduates. It's very important for education.
I'll be happy to do that.
Thank you.
So, see you in 2 weeks. Thank you very much.
See you then.
I wish you all the best. Thank you.
Bye. Thank you.
Bye.
Thank you. Bye. Bye.